Hope everything's going good. Hopefully you guys are working hard, getting caught up on some of your information, working on those logs. We're going to be using some of those properties that I taught you last time in today's lesson. So if you're still a little fuzzy, maybe this will help clear some of them up, hopefully. I'm looking at my examples. I did not pick enough, but we'll see. I've got like 5 to work through. So hopefully we'll cover some or enough that it makes sense. I hate these videos, so just enjoy the awkwardness of Miss Nelson on camera. Okay. So last time we talked about how to convert exponentials to logs and logs to exponentials. Without that skill, today's kaput. So, just a reminder, when we have a to the x equals y, this becomes the log base a of y equals x. Or vice versa. If we have log base a of y equals x, this becomes a to the x equals y. So, I'm going to keep that on the board, and we're going to work through some examples, different examples from different ideas of how we're going to solve our log equations. My mom's calling me right now. Do you guys want to enjoy this for a second? Mom, I'm filming right now. Yes. Okay, you're at Bridalveil Falls. You could just come to the school and then we could drive to the house after. Okay, do you know where the school is? Do you remember how to find it? Okay, bye. Well, that was my mom. Mom and Dad are coming to see me before the big trip, so. All right. Sorry, good times. Here we go. We're going to start with some examples of why we have logs. We're going to be solving for exponents. All right. So with this example, we're going to have 5 times 7 to the 5x power equals 60. Okay. So with this, before we can solve it, before we can use that log idea, we have to isolate the base. The base is the piece that has the exponent. So 7 to the 5x, that's the base. So the first thing I'm going to do here, I'm going to divide both sides by 5. So then I end up with 7 to the 5x equals 12. Okay? And now, the base is by itself, 7 to the 5x. I can rewrite this as a log. This becomes the log base 7 of 12 equals 5 times x. The goal is to solve for x to get x by itself, so I'm going to divide by 5. All right, so now I have x equals log base 7 of 12 over 5. That's what x equals. If this were a question where it said solve for x, I solved for x. That's how I do it. I isolate the base, which I did here, and then I isolate the variable, which I've done here. But as we move forward, we need to know what that value is. So we need to know how to plug that into a calculator. So what I'm going to do, to plug this into a calculator, we use what is called the change of base formula. This is going to go in the calculator as the log of 12 divided by the log of 7. And then I'm going to hit enter, and I'm going to divide by 5. The reason that we have to do this, if you look at your calculators, you have a log button and a natural log button, the ln. Log in a calculator always has a base 10. They don't write the 10, it's implied. So it would just look like this. This is how the calculator thinks. So we have to put the log in the language the calculator can interpret. Okay? If you see a natural log of x, that's because it's a log with a base e. E is a number. E is about 2.71828, and it goes forever, similar to pi. I'll talk about that more in detail when I am back in class. So again, to evaluate this, we're going to take a log base 7 of 12 divided by 5. In the calculator, the log of 12 divided by the log of 7, hit enter, and divide by 5. I'm just grabbing my calculator. So if you guys don't have a calculator, make sure you have one. So on my calculator, I don't know if you can even see that. All right, so I'm going to do the log of 12 divided by the log of 7, hit enter, and divide by 5. All right, log of 12 divided by the log of 7, hit enter, and then divide by 5. So my answer here, x, is about 0.2554. All right, if we're just solving for x, we can leave it here. But as we move forward, we've got to know how to plug it into a calculator, so I'm just going to give it a try. All right, let's look at another example. Okay, similar to this, just different numbers. Let's solve the following. I thought I hated erasing whiteboards before, and then I started filming myself doing it, and I hate it even more. So exciting. All right, so this problem, we're going to do 2e to the 2x minus 7 equals 5. All right. Again, the goal is to isolate the base. So this time, that's e to the 2x. So to isolate e to the 2x, I'm going to start by adding the 7 over. So we get 2e to the 2x equals 12. Still got to isolate the base, so I'm going to divide both sides by 2. And now we have e to the 2x equals 6. Okay? We've now isolated the base. Once the base is isolated, we use this idea and we convert to a log. So my base is e. When the base is e, this becomes a natural log of 6 equals 2x. Okay? And then I got to isolate the x. I divide by 2. So here we're seeing x equals the natural log of 6 over 2. We can't reduce the 6 and the 2 because the 6 is inside the natural log. It's not 6, it's the natural log of 6. So I'm going to ask my calculator here, and all I'm going to do is type in the natural log of 6, hit enter, and divide by 2. Okay? The natural log of 6, hit enter, and then divide by 2. So I get 0.8959. This guy is my exact answer, and this is a rounded answer. So if we're solving an equation isolating x, we can keep it as the exact solution versus the rounded. But if I ask for the rounded, give it a shot. See if you can make sure you're plugging it into the calculator properly. All right, this is why we have logs, so we can solve these types of equations. Sometimes our equations are already logs, so we've got to see how to solve those. So we got another example. All righty. So this one, we're going to look at the log base 2 of 3x minus 4 equals log base 2 of 5. Log base 2 of 3x minus 4 equals the log base 2 of 5. All right, log base 2 equals log base 2. So if I have a log that equals a log, well, then 3x minus 4 has to equal 5. If the log equals a log, the insides have to be equal. So 3x minus 4 equals 5. Solve for x. So I'm going to to add the 4 over. So I get 3x equals 9. And then I divide by 3. And x equals 3. When a log equals a log, the insides have to be equal, so we can ignore the logs for a minute and just solve the equation. X equals 3. Okay. Let's make this one just a smidge harder. All right, so for this example, let's do, oh, come on, book, don't fail me now. Well, I thought I had picked some good examples. We'll come back to that in a second. Our next type of equation looks something like the following. Let's do, I swear I planned this before, so, don't get mad at me. It's fine. Log base 2 of x minus 6 equals 5. Log base 2 of x minus 6 equals 5. All right? This time we just have a number on the other side, not a log. So we can't just ignore the logs for a second. When we have a log equaling a number and our unknown is inside the log, what we're going to do, we're going to rewrite it. We're just going to change this into exponential form. So this becomes 2 to the 5th equals x minus 6. 2 to the 5th equals x minus 6. 2 to the 5th. So 2 times 2 is 4, 8, 16, 32. 32 equals x minus 6. Then I'm going to add 6. So x equals 38. Okay? So we had two options so far. If we have a log equaling a log, what we're going to do is we're going to ignore the logs. Solve the inside piece. But if we end up with a log equaling a number, this is where we rewrite as an exponential. Okay? All I'm going to be able to do now is make these examples just slightly more complicated. All right? But that's the main process. If I can get a log to equal a log, ignore the logs and solve. If I can get one log equaling to a number, rewrite it in exponential form, and solve. Okay. What I mean by one log equaling a number. This example, if I have the log of 2x plus the log of x minus 5 equaling 2. I don't have one log equaling a number. I have two logs. But I can only do this if I have one. So we're going to use what we talked about before I left. If we add two logs together, that addition condenses to multiplication. All right? So I'm going to rewrite this as the log of 2x squared minus 10x equals 2. I took my 2x, I times it to x, and I times it to the negative 5. Okay, now I have one log equaling a number. I can rewrite it in exponential form. I don't have a base here. If I don't have a base, what is it? Okay, the base is always 10 if there's no log, or no base on the log. So this becomes 10 squared equals 2x squared minus 10x. We're left with a quadratic, so to solve it, we have to set it equal to 0. So I'm going to minus my 10 squared over. What is 10 squared? It's 100. So I'm going to subtract this 100 over, and now I'm looking at 0 equals 2x squared minus 10x minus 100. All right, to solve this now, I'm going to factor it. 2x squared, 10x, and 100 have 2 in common, so I'm going to factor the 2 out. And now I'm going to factor what are factors of 50 that'll combine to equal negative 5. So when I factor that, I'm going to get x minus 10 and x plus 5. From my factors, I'm going to get the solutions 10 and negative 5. So algebraically, these are my solutions. But like we talked about last time with the domain and range, domain of a log, we can never take the log of a negative number or 0. So I'm going to check. If I take 10 and I plug it back in, it's okay. I'm taking the log of a positive number, 10 works. But if I plug in negative 5 minus 5, that's a negative number. I can't take the log of a negative number. Negative 5 times 2, that's negative 10. I can't take the log of a negative number. Negative 5 worked algebraically, but it doesn't work in our log. It's an extraneous solution. So our answer is x equals 10. Okay, if our original equation was different, and I plugged the negative 5 back in and it made it positive, we could use the negative 5. It just depends on our initial log. All right, I'm going to work through one more example with you just to cover some questions. After that, I've got a worksheet for you guys to practice on, see how you're doing. If you're still a little confused, we can check Khan Academy or talk to some of the math aides, talk to each other. My parents might be outside right now. We'll see. All right. So, my last example, what I'm going to do, this is going to be the natural log of x plus the natural log of x minus 2 equals 5. All right. So I have 2 logs. I'm going to condense them together using multiplication. So this becomes the natural log of x squared minus 2x equals 5. I picked a really fun example, okay? So what I'm going to do, I have my log equaling a number. The base on my log is e. So I'm going to rewrite this as x squared minus 2x equals e to the 5th power. It's an ugly number, okay? Again, we have an x squared, so to solve that, I have to set it equal to 0. X squared minus 2x minus e to the 5th equals 0. Okay, at this point, to be able to solve this one, we're going to have to plug it into the quadratic formula. And I really don't want to do that, so I'm not going to. Now that I'm looking at that problem, it's a little messy. Good job condensing and rewriting it. We would solve algebraically from there. We'll try a new one. Let's see if I can pick a nicer one this time. Should have worked that one through. All right. Let's do a nicer problem. Those are all awful. You know what? I think you'll be set. The only ones I really want to talk about, I'll just make one up just for kicks and giggles. It'll make more sense. If we have the natural log of x plus 3 equals 4. Who knows what this is, okay? But it's going to do what I want it to do for now, okay? We have our log equaling a number, all right? The base is e. So I'm going to rewrite this as an exponential. E to the 4th equals x plus 3. Our goal is to solve for x. So I'm going to subtract 3 from both sides. I'm going to get e to the 4th minus 3 equals x. There's my answer. All right? All I want you to know with these types of questions, it's going to be left in terms of e. We don't have to take that to a decimal. We don't know what that means. As long as x is isolated, we're set. Okay. I know that's only some basic problems. I hope you guys can do all right. Give them a try. If you're still curious, jump on Khan Academy, watch some videos. The answer key's in the back of the book. Go ahead and work through those, see how I'm doing them. Give them a try, okay? You'll be working on these again and doing some review next class period, and I'll see you guys in a few days, all right? Thanks for all your hard work. See you guys.